In this video, we're going to use gas stoichiometry to solve a question. And the question says, ammonia, which is widely used as fertilizer, is produced from the reaction of nitrogen and hydrogen. What volume of ammonia at 450 kilopascals pressure and 80 degrees Celsius can be obtained from the complete reaction of 7.5 kilograms of hydrogen? Now, in any stoichiometry question, we're going to have a balanced reaction, organize our information, calculate the number of moles given, then transfer to the number of moles of required, and calculate an answer. So here it says that nitrogen gas and hydrogen gas are being used to produce ammonia. The balanced equation requires 2 ammonias and 3 hydrogens. It says that we have a volume of ammonia of 450 kPa. The temperature is 80 degrees Celsius, which is 353 Kelvin. And that's not the volume, that's the pressure. The volume is what we're wanting. And the mass of hydrogen is 7.5 kilograms. The molar mass of hydrogen is 2.02 gram per mole. Now, from this, I can calculate the number of moles of hydrogen because I've been given enough information, and I'm required to find the number of moles, or the volume of ammonia. In this, there are 2 things that are kind of a little bit different than some other questions. 7.5 kilograms is the same as 7.5 times 10 to the 3 grams. So I'm actually able to use either of these values to do this calculation. I'm going to choose to use 7.5 kilograms. And if you're not comfortable with that, by all means, use the grams. That's fine. But I want to calculate the number of moles of hydrogen. That's mass divided by molar mass. I'm going to use 7.5 kilograms divided by 2.02 gram per mole. Now the grams are going to cancel out, but that leaves kilos and moles. So I'm actually going to get kilomole as my answer. And I've got 7.5 divided by 2.02 gives me 3.7 kilomole. I'm going to actually retain this number through my calculations so I don't lose any of the, I don't multiply my errors by rounding each time. But the number of moles of ammonia is what I need. So that's what's required. I know I've got 3.7 kilomole of hydrogen. So that is going to put hydrogen in the denominator and ammonia in the numerator. And I get 2 ammonias for 1 hydrogen. So I'm going to take this number times 2 divided by 1, and I'm going to get 7.4 kilomole of ammonia. And once I know the number of moles of ammonia, then I can use PV equals nRT to calculate the volume. So the volume of ammonia is going to equal nRT over P. So I'm going to have 7.4 kilomole times R, 8.314 kPa times liters over mole times Kelvin, times the change in, or times the absolute temperature, which is 353 Kelvin, divided by the pressure, which is 450 kPa. So this is a large number of mole. I'm expecting to find a large volume out of as a result. So I'm going to times 8.314 times 353 divided by 450. And this is going to have my kilopascals cancel out, the kelvins cancel out, the moles cancel out, but I'm going to be left with kiloliters. So I've got 48 kiloliters of ammonia. If you had done this calculation using 7.5 times 10 to the 3 grams, what you'd have gotten was 48 times 10 to the 3 liters. So either one I think is acceptable and should be fine, but it's a little less work if you can keep track of your kilos. Anyhow, that's the second example of gas stoichiometry. You always use a balanced reaction, organize your information, calculate the number of moles of the given, the thing you have enough information to get, and then convert it to the chemical amount or mole of the thing you require. Then you use that to calculate something else.